Peptides are a chain of amino acids, essentially. So they fall between a small molecule drug and a biologic. There's some specific advantages for peptides versus small molecule drugs. And that's where we'll see just immense improvements when people have multiple peptides versus just one pathway. I think they've sequenced up to 7,000 different peptides in the human body. Anyone out there doing GLP-1s like your Ozempics or Mounjaro or tirzepatide, semaglutide, those can be super effective peptides. But what we've also seen is they can have some detrimental side effects. Welcome everybody to the Health Accelerator Challenges. This is your host today, Cade Archibald, and I am really looking forward to diving into some really cool content today. All right, so today we're going to go into our peptides, drugs, and intro to just general introduction into what peptides are, and so we'll dive into what are peptides, some of the origin and how they're produced. We had some really good questions at our retreat on Monday around this. And so we'll answer some of those questions, how they're the mechanisms of action with peptides. We'll go into that, some of the different pharmacological properties, and then kind of administration, bioavailability, capsule form versus injectable, nasal sprays, some things there, and let's go ahead and dive in here. So, and hopefully if you guys have been listening to us for the last little bit, hopefully you know what peptides are, but I'll explain those very basic level. If you're new to the show or maybe listening to a recording and you haven't heard our stuff before, hopefully this will be really insightful. Some of you, this may be a review, but what are peptides? So peptides are a chain of amino acids, essentially. So they fall between a small molecule drug and a biologic. There's some specific advantages for peptides versus small molecule drugs. Peptides are a little larger, more complex than your small molecule drugs. So they'll typically consist of up to 40 amino acids. They cover a surface area larger compared to small molecule drugs. They make them more effective at inhibiting protein-protein interactions and greater specificity and selectivity for their targets, potentially leading to fewer side effects. So what we've also discovered, and we'll probably talk a little bit about this in the mechanisms of action, but small molecule drugs will typically utilize a nutrient to actually create the effect, as opposed to with peptides. So there's just this amino acid chain sequence, and it can signal and open up different pathways. And so, you're just stimulating a certain pathway, opens up, and it allows your body to kind of utilize that as if it's functioning fully when maybe there's some dysfunction, and that dysfunction can be caused by, your typical triggers, infections, inflammation, toxins, things like that. And so it can be, peptides can really help open up those pathways. So simply put, peptides, chain of amino acids that open up different pathways and help create better cell-to-cell communication. And the analogy I love to use when it comes to peptides and looking at the body is, if you imagine you have you walk into a big, huge building and all the lights are off, big open warehouse, let's say, and you have that strip of lights, like the whole light switchboard on the side of the wall. And if you just turn on one or two of those, that room's going to still look really dim. But what's cool is peptides, if you get the right sequencing of peptides for what your body needs, you can actually turn on all the lights so your body's communicating more effectively. And so the light is like, peptides help shine a light in areas that maybe are dull, not fully functioning. And so, they can come in and they turn on all those lights. And now you can actually see, and there's better communication because your cells are able to communicate more clearly and fully expressive. And so it really, helps with your gene expression there. So that's my simple-minded way of explaining that for you guys. Some of the origin and production. So small molecule drugs. So, and you'll see some of the comparisons between, peptides versus small molecule drugs. But, small molecule drugs typically chemically synthesized versus peptides. There's a few different ways to derive peptides because they are naturally occurring in the body. So your body, I think they've sequenced up to 7,000 different peptides in the human body. And so you can get peptides from the human body. Naturally, you can get it extracted from natural sources, plants, animals, things like that. That's where a lot of the peptides come from, as well as they can be synthetically produced in a lab where they're looking at that amino acid sequence and they're creating that sequence in there. So it's, fairly versatile and flexible. You want to make sure you maintain that natural sequence and that specific peptide sequence. So some of the mechanisms of action here. So peptides, they have some really, really cool mechanisms of action. They can help recruitment of T cells. So your thymosin peptides, thymosin alpha 1, thymosin beta 4, that really helps with some of the T cell activations and differentiating in white blood cells, recruitment of dendritic cells. And this is what happens internally in our body, like all of these different peptides that are in our bodies can create some different actions there, like thymosin alpha 1 and thymosin beta 4. Those are in our bodies, but what's really cool is when we can actually accelerate how much is in our body and open up that pathway, or that, increase some of that peptide into our body so we can have better recruitment of T cell for our immune system. Increased wound healing. That's one of the first peptides that gets produced, is thymosin beta 4 when you get a wound or a cut. And that's actually pulling in stem cells from your body as well. And so that just creates a really synergistic healing capability. And so peptides can act as hormones, growth factors, neurotransmitters, or ion channel ligands. And so the mode of action, similar to biologic, binding to a cell surface receptors with high affinity and specificity. And, it's the big difference there, if you look at how these are being utilized compared to, maybe like your pharmaceutical, like a small molecule drug. Peptides generally have higher potency and selectivity for their target, faster onset of action, potentially longer lasting effects, and lower toxicity and better tolerance with each of the patients. So, if you think about how small molecule drugs, like take a statin, for example, statin uses a nutrient in the body to create that mechanism of action, which then actually depletes that nutrient. And so that's where you'll see a lot of, there's a lot more different side effects with a lot of these drugs in the marketplace, because the way it's being activated, it's not a naturally occurring substance in the body. It's more of a chemical. And so when it enters the body, it uses specific nutrients. So CoQ10, for example, in a statin drug. So if you're on cholesterol lowering medication statin, that is actually using CoQ10 to activate, and it depletes CoQ10 in the body, which CoQ10 is super critical for heart health, joint health, elasticity in your tendons and ligaments. And so definitely if you're taking that, make sure you're supplementing with some good CoQ10. And so, those are some specific things to consider. But what's really cool about peptides, they don't necessarily they're coming in their naturally occurring sequence that the body's already accustomed to. And so really you're just accelerating that specific function for your body. And so, that's going to help with, different autoimmune conditions, potentially wound healing, gut healing, like BPC 157. We produce that, and it's in our gut is where you'll typically see BPC 157 being produced or very active. But if you accelerate how much is in there, you give your body a nice boost. Now you're able to heal even faster, clear up some leaky gut and all sorts of just awesome things when it comes to some of these peptides. And so, yeah, some really fascinating things. So let's talk a little bit about how it can be administered when it comes to peptides, how you can do subcutaneous injections. There can be capsules, and obviously there's nasal sprays. There's all sorts of different administrations, but peptides, if you think about it, ideally most peptides that people learn about are injectables. And the reason why most of them are injectables, and our technology is getting better and better, and that's how we're able to find more and more encapsulated options. But historically, subcutaneous injections has been kind of the preferred method for peptide administration because they're super sensitive. And so, unlike kind of small molecule drugs, those can be in capsule form and they can make it through the digestive tract very easily. Whereas peptides are super sensitive because they are this very natural created sequence. The digestive tract can just break those down before they make it into any sort of helpful absorption. But now we're finding better and better applications, and there's ways that some of our pharmacists have been able to add on some different electron chains so they can make it through the digestive tract better, or even just the encapsulation forms. You can make it through the digestive tract better. Some peptides, it just makes a lot more sense to do injectables. I know all of us are like, hey, when can we get everything in a capsule form? Which I wish it was really easy to get every one of them in a capsule form. But yeah, we're working on more and more options there. But yeah, typically, you subcutaneous injection, it's a little teeny poke, not too bad. And you definitely get that full expression. Whereas, some of these capsules get broken down. The nasal sprays, we've seen it be very super impactful, especially with some of the brain peptides like Selenk and Cmax, RG3 synapsin. Those are all some really good nasal spray peptides that like you can feel the effects. So very, very bioavailable there. And yeah, just fantastic. All right. And some other things. So peptides actually show less immunogenicity. That's the ability to trigger an immune response in the body compared to larger biologics. So that reduces the risk of adverse immune reactions. It's very typical injection site tenderness, itchy, maybe a little lump there over time. But yeah, not many cases at all where there's like an extreme immune reaction because they do have, a lot less immune triggering aspects to them. But yeah, it can be really helpful. There's great peptides to help with the thymus gland, spleen, lymph nodes, all our different organs in our body that can just essentially you're creating better communication. If you go back to some of the mechanisms of action and how peptides can be super helpful, they're very dynamic. They can act as, similar to a hormone, different growth factors, neurotransmitters, because ultimately they're just helping create better expression in those genes. So you create, better hormone communication or better hormone signaling. You can increase your growth factors and some of your neurotransmitters. So very, very dynamic when it comes to these different peptides. Let's see here. And then ultimately what, with peptides, just to give you a little review here. So what peptides are, you have a small chain of amino acids that can help with enhanced signaling and communication. They can come from different sources, so their origin. They're naturally occurring in the body. They can be created from plants, animals, as well as they can be synthetically created in a lab with very specific sequence. So, they're pretty dynamic there and very safe. Even in the synthetic, some of the synthetic peptides is if you're getting that same amino acid profile chain, that's actually, you can create that to be very therapeutic and very effective to get, really, really big action. Their mechanisms of action, they can really, almost mimic hormones, growth factors, neurotransmitters, help with the ion electron chain, and very, very, bioavailable through injectables, through if you think about, if you're taking capsules, usually if we've recommended them to you, we've tested them and they have really good bioavailability. But that is one of the concerns. If you're just grabbing some good old peptides off the internet, you want to make sure that you're actually getting what think you are receiving, like making sure it is actually the peptide that's being talked about on the bottle, but also you want to make sure that it's going to be usable in the body. And that's where it becomes pretty challenging. Great question. So had a question come in. What would cause a person to do better with one peptide at a time versus stacking them, taking more than one at a time? So what would cause someone to, I'm just going to stop sharing here. So the question, I'm not sure what would cause a person to do better with one peptide versus stacking. Our experience is stacking because you're turning on more light switches at the same time. And that's where we'll see just immense improvements when people have multiple peptides versus just one pathway. So I don't know if you're referring to that's someone's experience or you're just asking if that's an instance. But with our experience, stacking is definitely much better. Like if you're anyone out there doing GLP-1s like your Ozempics or Mounjaro or tirzepatide, semaglutide, those can be super effective peptides. But what we've also seen is they can have some detrimental side effects if they're only used with those. It can be, lead to whether it's muscle wasting or, kind of Ozempic face, things like that, versus if you can stack those with some growth hormone releasing peptides, as well as, getting the right amounts of protein and macronutrients is super critical, because if you're not doing those, you're not feeding your muscles some good protein, you're just going to be withering away. And that's, if you lose a lot of muscle, that has its own downstream effects. Losing a lot of weight, primarily muscle, is never a great thing. Hopefully I answered your question there. Awesome. Well, that is the show today. So hope you guys really learned a lot. The challenge this week, I'll give you the challenge too. Hopefully everyone on here is part of the East West Health community. You're doing your peptides on a regular. If you're not doing peptides, let's reach out and figure out what would be the best peptides for you. If you are already doing some, and I mentioned a few peptides that maybe you're not taking or you don't know, get some clarity. Ask your executive medical provider what type of peptide. It could be a growth hormone releasing peptide. That's like one category. You'll see like CJC, a 1295, or you'll see like the GLP-1s or the weight loss peptides, some of your immune peptides or recovery peptides. So recovery is going to be like your BPC 157, thymosin beta 4, your immune system peptides going to be thymosin alpha 1, ABP 7 is another good one, LL37. Those are really good immune building peptides. And the list goes on and on, but yeah, just figure out what categories you're taking. And, ideally our plan is to, help stack those over months of time. So you're really priming each of those pathways consistently. So that's all we got tonight. Hopefully you guys learned something new today, and we will be back same time, same place next week. Have a great night, everybody. Bye-bye.